Pythagorean Theorem, Part 1. So the question for this lesson is, what is the relationship among the legs and the hypotenuse of a right triangle? So when we're looking at this triangle, we have different parts. We have legs and a hypotenuse. A right triangle is a triangle with one right angle. Usually it'll be noted with a little square in the corner. The legs are the sides that form the right angle, and the hypotenuse is the side opposite the right angle. It is the longest side of our triangle. So let's go ahead and label the legs and the hypotenuse. Let me turn this sideways. This is a leg. This is a leg. And this is our hypotenuse. You can think of the hypotenuse as that sliding portion. It's the longest side also. Now, when we're looking at the Pythagorean theorem, you'll notice that each of these sides is labeled with a variable. You have A and B, which are our legs, and then you have C, which is the hypotenuse. And you're going to see A squared plus B squared equals C squared, which is our formula for right triangles. So the next activity asks you to cut out 3 squares. That's a 3 by 3, a 4 by 4, and a 5 by 5. And you're going to use them to create right triangles and glue them into your spiral, which if you got a new one, fantastic. If not, you can do it down here. And I already have mine cut out. I'm going to set those right here. So I have these 4, and that 3 by 3 is a 9, the 4 by 4 is a 16, and the 5 by 5 is a 25. So how are all of these squares related? So I'm going to take my triangle. I'm going to set up, I have the 3 by 3, the 4 by 4, and this 5 by 5. And notice that the edges of this triangle are 3 by 4 by 5. So when we're looking at this relationship, we could say the square of the two legs, the sum of the square of the two legs is equal to the square of the hypotenuse. Because notice 9 plus 16 equals 25. So if you do have a spiral or you have a sheet of notebook paper, it's going to look like this. So you take the square of each of these, the square root of 9 is 3, the square root of 16 is 4, and the square root of 25 is 5. So for taking the area of each of these squares, are 3 by 3, 4 by 4, 9 plus 16, that 5 by 5 is equal to 25. Or we can rewrite this as 3 squared plus 4 squared equals 5 squared, which is where we get our formula of A squared plus B squared equals C squared. And you can use this on any right triangle. It only works with right triangles though. And if you need to pause the video to copy it down, please do so. So here at the bottom, let's write the sum of the square of the legs is equal to, what is it equal to? What did we say it was equal to? Remember? The square of the hypotenuse. All right. So on the next side, and if you printed these off individually, it's going to be on the next page, because these typically, for my students that already know, they open up like this, and with a little booklet. So that second page is actually the inside of the little booklet. So will the sum of the square of the legs equal the sum of the square of the hypotenuse of this right triangle? So we have a 6, 8, and 10 side lengths on this triangle. It says that we have a right angle here. So let's prove it. So we're going to take 6 times 6. 8 times 8. And 10 times 10. Add your two sides. 36 plus 64 is 100. So yes, this actually is a right triangle. I know we see the right angle there, but we still need to prove it. Let's try another one. So here's our Pythagorean theorem, which is just what we wrote on the front side. And there's a try it. So the measures of the three sides of a triangle are 5 inches, 12 inches, and 13 inches. Determine whether the triangle is a right triangle. So we're going to take this again. We want the two shorter sides. The square of the two shorter sides, is that equal to the square of the longest side? We take 5 squared plus 12 squared. Is that equal to 13 squared? And here we go. If you need to use your calculator, probably know the 5 and the 12, but maybe not the 13. So 5 squared, 12 squared, and 13 squared. From here, what is the sum of the legs? 25 and 144. That is 169. So this is a yes. It is a right triangle. On the next side, converse. So when we're talking about the converse of the Pythagorean theorem or any proof, we're taking the if-then part of the statement and we're going to reverse it. So here we have, if a triangle is a right triangle, then a squared plus b squared equals c squared. Therefore, the converse would be if a squared plus b squared equals c squared, then the triangle is a right triangle. Is the converse true or false? Well, we know the statement is true, but we know that if a squared plus b squared equals c squared, then that will give us a right triangle. So this one is true. They're not always true, but this one is. So on the next section, if you would, you're going to determine whether each triangle with each given side lengths is a right triangle and justify your answer. Now, a lot of students look at that and go, oh my gosh, justify my answer. We'll show your work. Show your work. How are you getting that answer? And also be careful, because you'll notice this one gives you 36, 48, 60. They're in order from smallest to largest. But this one, E, is not. It's a 4, 7, and a 5. So just be careful, because they're not always going to be in order. So let's set up this one. 36 squared plus 48 squared. Is that equal to 60 squared? The second one, our two legs are the 4 and the 5. So 4 squared plus 5 squared, is that equal to 7 squared? Why don't you pause the video, try them out, and see if you're right. So if you work through this one, you're going to find that this is a yes. I hope you got that. Whereas the second one here, this one proves as no. So again, 4 squared is 16, 5 squared is 25, 7 squared is 49. 16 and 25 gives us 41, which is not equal to 49. But these two will equal the same. And you do need to make sure that you're probably using a calculator here. It'll take you a little while if you don't. But these two will come out equal. So on the reflection, the area of the square of the lengths of the legs is equal to the square of the length of the, what you got? That long side, hypotenuse. So there are practice problems on the very, very back. If you want to go ahead and work those out as a little bit of extra practice, you can. Send me a picture of it in my email and I will give you pirate bucks. Okay? And until the next video, enjoy the Pythagorean Theorem. It's a lot of fun.